I will now discuss multi-stage model of ambiguity where the stages are endogenous, and this figure will help explain. We've seen a similar figure before, but then there was uncertainty about the color of a ball drawn from an Ellsberg urn, and there were only two states of nature in fact. But here I'm going to assume a general state space, general states of nature. Capital S is a general state space. It can have, here I depict it as if there's finitely many and many elements. It can also be infinite, but for simplicity of the figure, I drew it as finite. But anyway, I want to assume now a general state space capital S. Well, that's a sort of a small mathematical generalization. That is not the essence of the difference that I want to discuss between endogenous and exogenous. That the essential difference we see if we look at these branches here, the branches that depict the second stage uncertainty, the uncertainty about what the probability measure on the state space capital S is. Before, in the exogenous approach, I would specify events on these branches. I could define them in physical terms, like the composition of the urn, and these events, they implied what the probability measure on the state space was. We don't do that now. Now we condition directly on that probability measure itself. So we simply say if the probability measure on S is P3, then this. If it's P7, then that. You can imagine that this is in itself is a realistic picture of what is going on in the minds of subjects. It can be, well, we do the as if yoga, that, but I'll talk the as if approach of economists, where these things may be happening subconsciously. But it's you can imagine that the subject facing a decision situation sees the state space and knows in as if sense that the probability, it's not clear what the probability is, and then it's conditioning. If the probability is this, then this happens. If the probability is that, then it is so and so. So that the conditioning is directly on the probabilities without the intervening event. That's you can imagine that. A drawback is that these things, these events, these conditioning events become less clearly observable. In the Ellsberg urn, the composition of the urn, in principle, you can open the urn, you can inspect what's inside the urn, you even can define gambles on it and do it. Here it's more difficult. How can you see that the true probability for this subject in his perception sense that is P5 and not P4? How can you determine and implement gambles on what the true probability on the state space in the perception of the subject should be? That's already hard to imagine. So that is a drawback of this approach. There's this observability problem. But there's a big pro to this approach, why people do it, why we have to do it, why it's important, why we should study this approach still. That is, this approach in principle is a general approach for decision making under ambiguity. Every situation of decision making under ambiguity in principle can be modeled along these lines. That was not the case with the exogenous approach. In the exogenous approach, you have to have these conditioning events available that you can define in physical terms. Well, in Ellsberg, we can do it, the composition of the urn, but in most applications, we cannot do that. Therefore, the exogenous approach is a quite limited approach. It can't be used very often, but this endogenous approach, in principle, can be used always. So that's a big advantage. Now, in the verbal slides, I write some text, I already said it. But now here's a new point, and that is in this endogenous approach, something it has in common with the exogenous approach is, let me see, if we look at these uncertainties, these second stage uncertainties about the probability measure on the state space capital S, we assume that that second stage uncertainty can be probabilized. Let me add it in the figure. We assume that probabilities are given, and that, for instance, we can specify a second stage probability small p subscript 1, that the probability measure on capital S is capital P subscript 1. We can do that. And well, I drew here as if there are only finitely many probabilities on S possible. Usually it's infinite, but for simplicity of figure, I did it like this, finite. And then let me one more mention. Here, small p subscript m is the second stage probability that the probability on capital S is capital P subscript m. So we do assume that the uncertainty in the second stage can be probabilized in this manner. So this, the approach has in common with the exogenous approach. Then we also assume, as we did before, that backward induction is used to evaluate. And that does mean, again, that reduction of commodity assumption is violated here. Now, some reference that I also put up in the exogenous approach. These authors, in fact, the papers, also they refer and allude to the endogenous interpretation. They can also be used in the endogenous interpretation. So let me also list them here in this endogenous approach. Already said, we have here the endogenous approach gives in principle a general ambiguity model that can be used in principle for all decision situations under ambiguity. It's hard to observe, I already said, but also it's very general. What I mean, what is the free parameter here is the set of all the second order probability distributions. That means all the probability distribution over the set of all the probability distributions over S. That's very high cardinality dimensionality. So it's way too general to be tractable. Well, we've seen before models that were too general to be tractable. Then they can still be a good starting point. Specification have to be added. But this is more general than anything we've seen so far. So here, surely specifications must be developed and people are working on it and it should be done. We need it here more than anywhere else almost. There's another sort of technical difficulty or maybe conceptual that I want to not discuss very much, but I want to say a few things about it. And that is, I already did say that these events that the probability on capital S is P5 and so on, these events, it's hard to imagine how you could observe them and how you could do gambles on them. That's even the problem gets worse if you know that in many papers, for instance, the most popular paper on this approach of this kind is the smooth model. I'm going to discuss in the next slides. They do allow that these probabilities here are subjective, not objective, but they can be savage type subjective probability distributions. That makes it even harder to imagine how they could be observed. For instance, if you want to gamble on them, and in a smooth model, such gambles are called second order acts. Then, for instance, it can happen that I face a gamble. It says if your subjective belief of rain tomorrow is 0.5 or higher, then you get €5,000. But if your subjective degree of belief of rain tomorrow is less than 0.5, then you have to pay €3,000. So I can be facing gambles like that, and they are very hard to imagine what they mean. How can you observe them even conceptually? Well, the authors of the smooth model do discuss this. They do also point out that it's hypothetical, and that is a point for further improvements and for future work to come. So this is generally known and acknowledged. But one improvement could be if in your model you could only work with acts of which the outcome depends only on what the true state of nature is, and not on what the probability measure over the state space is. And if you could do your mathematics and profit foundation, all these things, using only those acts, that would be a big improvement. And this people haven't yet been able to do it. It's an open question. That would be a desirable advance to be made. Anyway, so all kind of problems still going on. So I already said a very popular version of this endogenous approach is the smooth model of these authors. The smooth model is assuming expected utility maximization in both stages, but different utility function, and usually more concave in the second stage to get the ambiguity aversion. This is then, in fact, the endogenous version of recursive expected utility model. And maybe today, when it comes to calculation numerical analysis, the smooth model is the most popular ambiguity model, the most widely used one. So I'll discuss a bit more the pros and the cons of this model. Pros, I already said, it's a general model of ambiguity, and then mathematically convenient because expect utility, we know that function. We need not buy new computer programs to do the analysis. Another big pro that I didn't mention yet was the smoothness. It's the authors put it central even in the name of the model, because the functional that they have, it can be differentiable. And that's often in economic analysis, we want to do first order optimality conditions, then differentiability is really convenient. For instance, the rank dependent model is not always differentiable, so that's an inconvenience of that model. So here's another analytical pro, tractability pro of the smooth model. But there are also problems, cons. And for instance, the cons that I mentioned for the exogenous recursive expected utility model continue to hold here. And I discussed that it's not homeomorphic, psychologically, ambiguity is how people feel about events, not about outcomes. This model is having functions like the recursive expected utility model. In the smooth model, the functions operate on the outcomes. So the set of outcomes that you face determine what your ambiguity attitudes, not the events that you face. And that doesn't feel like psychologically realistic. So that's already, I think, a point of concern for the model. Related to this is that empirical problems are there. And the prevailing empirical pattern for ambiguity attitude is this fourfold pattern. I said it before. And for gains, you have ambiguity seeking for unlikely gains, ambiguity aversion for moderate or high likelihood of gains. And so it depends really on the events. The smooth model cannot accommodate that. Only the outcomes decide whether the event is likely or unlikely, it doesn't matter. So the smooth model cannot work well empirically, I think. So that's another problem for the model. Then I already discussed that this endogenous two-stage setup is unobservable, also too general as it in full generality. So now, in I think all the experiments that I saw of the smooth model, people would always take that two-stage decomposition, exogenous. The experiment would already specify a few probability measures that would be the candidates, maybe even take Ellsberg urn, where we can refer to the composition of the urn, this exogenous event. I don't think I ever saw an experiment where really the two-stage decomposition and the second-order probability distribution was kept endogenous, completely derived from preferences. I haven't seen it yet. Here, it's a bit paradoxical. The two-stage model has a problem like the multiple prior model. That is, to be a general model of ambiguity, it has to take this two-stage setup or multiple prior set of priors. It has to be taken endogenous. However, people don't really know how to handle this. So in all the application, on the experiment, these things are taken as exogenous. So that's still, where the models are not new. So the novelty of the model is still to be developed and more work to be done there. Anyway, people do use a smooth model. Maybe it's the most used model now because it's so tractable, but more work should be done. That should be clear. And one more thing is you can always do parametric fitting. Every model you can do parametric fitting, but if you have general models, and especially the smooth model is very general in its full generality, multiply is also quite general, rank dependent a bit less. But then if you have very general models and you do parametric fitting, then the implication that you get, they are almost more and more determined. The more general your model is, the more they are determined by the parametric families that you assume, the parametric assumption that you make, and not by the model itself. So then more and more you must justify why you made the parametric assumption that you did. And I don't think that happens. Usually in the literature it's quite more or less ad hoc. People make parametric assumptions. So this is another point where more work is needed and why it is desirable to develop special cases. That is all to come for future work, and maybe future researchers and generations can do that. And people listening to this recording may contribute to that, to such improvements. And so we all look forward to that. But I finished recording here. Next recording will be other ambiguity models and applications.